Good afternoon, everyone. For today's class, we will talk about linear regression and correlation. As I've been doing for the past week, we start with the keywords and key phrases. So this lesson is divided into two. So as you can see in the title, linear regression and correlation. But however, we'll discuss first correlation. So for the first part, the keywords or key phrases are the following. So please write this down so that later, if you want to add some details into them, you can do that later. So we have variables, two variables. Next, we have the correlation, the word correlation. Next is the linear correlation. And then the fourth is, please insert there also scatter plot. Okay, so maybe that's the fourth, scatter plot. And then the fifth one is the coefficient of correlation. Okay, so that's the first part, the keywords and key phrases. Now, for the part two, linear regression, these are the keywords and key phrases. So we have the variable still, but this time we will differentiate dependent from independent variables. So independent variable, usually we denote it as X, and then dependent variable, we denote it as Y. Okay, so we have two variables. Unlike the first part, we don't mind which one is X, which one is Y, as long as we have two variables, okay? Because we just want to get the relationship between these two variables. So in part two, we mind them. We mind the whether we have, in fact, we have to determine which one is independent, which one is dependent variable. For us to be able to get this one, the next key phrase, the regression equation. Okay, the regression line, the equation of the regression line. Okay, so regression line. And then the next one, the next keywords or phrases, the coefficient of determination. Okay, but please include there also linear regression, because there's what you call multiple regression. No, but here our focus is linear regression. If last week our focus is descriptive statistics, for this week our focus is inferential statistics. Remember, I told you there are two types of statistics: descriptive statistics, where you describe your data based on the three measures, right, of the descriptive statistics, which we studied last week. And now for this week, we try to predict, no, our data based on the sample, okay, based on the what we're going to obtain for today. Because for part two, we will try to obtain, the objective of part two is we would like to obtain our equation of regression, the equation of the regression line, and also the coefficient of determination. Whereas in part one, our objective is for the correlation. No, for the correlation, our objective is to find this coefficient of correlation, because this coefficient of correlation tells you the strength of relationship between these two variables. Again, in relation, we don't mind which one is dependent, which one is independent. That only matters in part two, when we talk about linear regression. But in correlation, as long as we have two variables and we'd like to find out the relationship, just the relationship, we don't even mind the causality. When you say correlation, you don't talk about causality. You only talk of relatedness or relationship of these two variables, or we want to associate one variable to the other. And now if you want to know the strength of the relationship or relatedness between these two variables, we compute for the coefficient of correlation. That's the objective for this part. So now let's go into the topic. First, let's discuss correlation in general. So a technique used to measure the likelihood of two behaviors relating to each other, as I've mentioned, relating, relationship, no, association, that's correlation. According to Guilford, a coefficient of correlation is a single number that tells us to what extent two things are related, to what extent variation in one go with variations in the other. Okay. Though there's multiple regression, but that's not our topic for today. We're just after the two variables, because once we have multiple regression, we're after we want to know the relationship of more than two variables, but we're just after the relationship between two variables. That's why this linear correlation, no? Not multiple. Okay. And in fact, our focus here is linear, because there are a lot of examples of correlation, but our focus is the linear correlation, because later on we will connect this to linear regression. Okay, so expect that somehow we want a relationship which is linear. Okay, because we can have what we call this quadratic relationship. No, but we're not after that kind of correlation. We're after with the linear correlation. That's why later on, there's this value, this coefficients, which will tell you the strength of this linear relationship. And now to illustrate correlation, we can use scatter plot. That's why it's mentioned here. The scatter plot explains the correlation between the two attributes of variables or attributes. Okay, it represents how closely the two variables are connected. There can be three such situations to see the relationship between the two variables. So since this is linear, remember the slope. It's connected to the slope. So anyway, first the positive correlation, then we have negative, and then no correlation. Because if it's positive correlation, the slope is positive. That's why I connect it to the slope. Later on, we'll talk about that slope. Now, positive correlation, when the value of one variable increases with respect to another. Remember, that's the one with the line with a positive slope. As one increases, the other one increases. So here we can talk of X and Y also. But again, in correlation, we don't mind which one is dependent or independent. Now, negative correlation, when the value of one variable decreases with respect to another. Now, no correlation when there is no linear dependence or no correlation between the two variables. Scatter plot is a graph, no, like this. So for positive, visually or graphically, we can say that the positive correlation is strong if we have this kind of graph. So we will plot the points. How did we plot these points? We consider the two values. Probably this is the X value, this is the Y values. But again, it doesn't matter if this is A values or B values. It doesn't matter which one is dependent or independent, as long as we have two variables. Now, if the data are plotted this way, close to the line, then we have a strong positive correlation. However, if the data are spread far from this line, we can say that the capacitive correlation is weak. Now, what is this? It's similar to this one. It's the moderate positive correlation. No, meaning to say not very far, not very near, moderate. The data are not very far or very near. But this one, your data are very near to the line. In fact, this is the one I mentioned to you in the keywords, key phrases. So in the part 2, we will try to find this line, this regression, this equation of regression line later. For now, we're just studying the how close this data from this line. Now, if they're very far, that's weak. Now, for the negative correlation, the same thing. We have strong, we have a moderate, we have weak. Now, you notice the slope, right? Because here, you'll notice once you get the regression equation or the regression line, the equation of the regression line, you will see that the slope is negative. Now, whereas for the other one, if the slope is positive, we'll have this equation, this graph of the graph of this regression equation. Now, if there's no correlation, expect that your data are very spread. Where will you put your line? There's none. You cannot put any line, draw any line here. So that's a correlation. Now, the correlation, you can illustrate it graphically, but there is an exact measurement of correlation where we use numbers. Okay, we use numbers. This one. Okay. So this is the formula to get. Once you get the answer, you can interpret using this table. So in statistics, the person correlation coefficient, also referred to as persons R, the person product moment correlation coefficient, or the bivariate correlation, is a statistic that measures linear correlation between two variables X and Y. It has a value between +1 and -1. So you notice linear correlation. So again, we're after the linear correlation, not quadratic, not any correlation, but linear correlation. And between the two variables X and Y. But X and Y here have nothing to do with dependent, independent. This can be any variable. You can use any variable here. It doesn't matter which one is dependent, independent. That matters in the second part. No? Now, if you want to get the coefficient of correlation, so we can just call this coefficient of correlation, which we denote as R if it's sample. Remember sample. Now, if it is population, we use the raw. Remember I told you, if you want to use the formula for population, we use Greek letter. So we'll have a different formula for that. So since we're after the sample only, we'll just focus on the sample formula of the coefficient of correlation. But in the computation later, we will use this formula. They're the same. These two are the same. But in the example later, we will use this because this one is easy to manage than this one. This one, we have to find the mean. Because remember, the sample, this X bar is a mean, sample mean. This is mean also. You're given two sets of values, X and Y. So these are the individual data values for X, individual data values for Y, and then we will get their means. But here, we don't have to get their means. No, we just have to have a table. No, you'll see this later better. No? Now, so I mentioned the meaning of these values. Now, how do you interpret? For example, you compute already, you get this value between 0.9 and 1. You say very high correlation. If it's negative, very high negative correlation, and so on and so forth. So numerically, we can describe your correlation in 4 ways. Very high, high, moderate, low. Whereas graphically, we can have 3 ways. Strong, weak, moderate. Okay? Strong, weak, moderate, and no correlation. If you want to show it in terms of the scatter plot. Okay, class? Now, the person product moment correlation coefficient, or person correlation coefficient for short, is a measure of the strength, as I've told you, of linear association between the two variables, and is denoted by R because we're focusing on the sample. Basically, a person product moment correlation, or simply the coefficient of correlation, attempts to draw a line of best fit. Okay, what is this line of best fit? That's what we will discuss later in part 2. It has to do with this line, class. In the scatter plot, we will find this line. So we will learn that there are formulas also to find this equation of the line. So remember the linear equation, right? The slope intercept. We have y equals mx plus b. So that's what we will do in part 2. Remember, the objective in part 2 is to find the equation of the regression line, and denoted by what? Y equals mx plus b. You learned that in high school already. So there, to get that, you have to find your slope, your m, and b, the y-intercept. That's what we will do in part 2. Okay? But we have to find which line, because this one is also line, but we can also draw another line, right? But based on statistical analysis, we can find the best, what we call the best, mentioned here, the line of best fit, using the statistical analysis and using those formulas. We're sure already that's the line of best fit if we use those formulas given in part 2. Okay, we don't have to, find it. We just have to use the formula, and we can get the line of best fit. Because if you will look at the graph, as I've mentioned, where will we draw the line? How will we know which line? There are a lot of points here. Which one will tell you which one is the best line, the line of best fit? How will you know? No, you just have to apply the formula. That's all, and you will get that line using that formula for what? For m and b. There's a formula to find m and b, the slope and the intercept in part 2. Now this is correlation. We're still in correlation. So I just told you in advance because it's mentioned here, okay? Now this is the example, class. No? So here we want to find the value of correlation coefficient, or the coefficient of correlation, right? Given these two data. So this one are your data value, the two variables that I mentioned. But this one, it doesn't matter which one is your x or which one is your y. But later on, we will relate this to linear regression. That's why for now, we just use x as your age and then glucose level as your y. Because later we might, I might show you later, but this is not the example used in part 2. But I prepared, what do you call this? I prepared an Excel file regarding this too. Okay, so anyway, I'll show you first the computational part. How to get the, given this data, how to get the coefficient of correlation, how to get R. Okay, so we will compute this, class, xy, x squared, y squared. Why this 3? Because in the formula, class, we have this 3 in the formula. We have xy, we have x squared, and we have y squared. That's why we have to compute them, so that later on, once we compute them, we will just substitute into the formula. Okay, so that's the objective. That's why we have this. So we will compute xy. All you have to do to get xy, just multiply them. 43 times 99, you get the answer, and so on and so forth. And then to get the x squared, just square 43. 43 times 43 is this. 21 times 21 is 441, and so on and so forth. And then you get the y squared. The y is this. 99 times 99 is this. 65 times 65 is 4,225, and so on and so forth. And then, since in the formula you have to get the summation, right? You will add all of this 3. There, you right? You also have to add this because you have summation of x. You have to add this, add all of this also. Add all of this because you will use all the summations in the formula. So this is the formula, right? We will use this, not the other formula. Since this sample we use R, then we just substitute, class. From the previous slide, we get these values, right? We just substitute. Once we substitute there and compute, the answer will be this, 0.529809. Okay? So that is your coefficient of correlation. Now, how will you know? How will you describe your data now? So again, still describe, right? Oh, even though this is inferential statistics, however, we put this under inferential statistics because it's connected to the regression equation, which is under inferential statistics. So how do we describe your data now, or the correlation? How will you describe? Moderate. Why? Because this one is 0.52. If you go back to the table, Where is the table? Oh, that's very far. 0.52 is this, right? Between 0.50 to 0.70 is moderate positive. If you get negative, you say moderate negative correlation. That's the reason. You just have to use this table. So it's easy class, right? You just have to use the table and this formula. However, there's an easier solution. Instead of computing, we can just use, remember the program, the software. So the Excel file is a software. We can compute this using the Excel file. Okay, without doing this, this hard work here. But you should know also this one so that you'll understand the concept better. And then we'll go, before we go to simple linear regression, let me show you the table, the Excel file. Everyone can see the Excel file, huh? So this is the Excel file of the age and glucose level. That's what we discussed, right, a while ago, the age and glucose level. So this is the scatter plot of this data. So to do this, I just use Excel file, but I don't have time to use. I cannot, maybe we can have another class for that, to illustrate how to use the Excel in computing this, as well as the lessons we discussed last week about data management. We can also use Excel to get the mean, median, mode. What else? The standard deviation, the range, the variance, or even a percentile, quartile, or even the box and whisker plot. But for this lesson, which is about linear correlation or linear correlation and linear regression, we can use Excel file. But there's another software, the best software, which is the SPSS. But I don't have that now. That's why I use the Excel file, but I won't illustrate to you. I'll just explain this to you for now. So the scatter plot, so this one, 43.99, this one. So this is the age, this is the glucose level, okay? So scatter plot class, but later on, I will use this if we have time to connect to linear regression. No? So anyway, this is the scatter plot. And then the coefficient of correlation is there, the same. You notice, the same, 0.52980. So I just used I did not go through that table at all. I just used this. So I used the insert, okay, insert, for example, insert, and then function there. And then I will find there the correlation, because I use correlation. Okay, I use this. I put there, and then there you have it. Okay. If I want to recompute, I will put it here, there. And then I will use insert. This is Excel file. And then insert, where's the formula? There's not here. Wait, because it's here already. So instead of using I will use this. Wait, I think it would take a long time if I use this. The formula, there, insert function. So I will find here. So all I have to do to find here, correlation. So I'll just have to put this like that. Okay, but I cannot illustrate now. That's for the correlation, no? To find R, coefficient of correlation. So if I do that, I'll go to this one. Okay, but I won't discuss that further. Okay, class? I just want to illustrate to you. Now, I'll connect this one to the next lesson. The next lesson is what? The linear regression. So this is what we want to find out, this orange here. We want to find the equation of this line. Connect this orange, you will have a line. So this line is what you call the regression equation, or the regression line, or the line of best fit. We know this is the line of best fit because this is based on the formulas of getting the slope and the, what's the other one? The intercept. And there's also a way to use Excel to get this, but I cannot illustrate that to you now due to lack of time. So now let's proceed to the lesson. I just showed it to you. Later, I showed to you the other examples given in this simple linear regression. Okay, what is simple linear regression? So I believe you have an idea already. I don't know if I will still read this to you. Anyway, let's try it. A simple linear regression analysis is a technique that is used to model the dependency of one independent variable upon one independent variable. Remember? So it matters now which one is dependent, independent in linear regression. There is this relationship between these two variables is explained by an equation. Regression and correlation are actually fundamentally the same statistical procedure. The difference is essentially in what your purpose is, what you're trying to find out. In correlation, we are generally looking at the strength. Remember, I told you that strength of a relationship, particularly what relationship? Linear relationship between two variables. How do you find the strength? In part one, you compute for the coefficient of correlation and you use the table. Remember the table to find the strength of X and Y. Now, what if you want to predict the values? When you say predict class, for example, this one, the first part has to do with age and glucose level. What if the question is you want to predict the glucose level of that person whose age is 75. How will you know? You cannot know from here if you don't have the equation. So you will use this lesson now in part 2 to get the slope and the intercept. Now using the, what do you call this? The Excel file, I was able to find the slope and the intercept. So now this is the equation, that's because that's what we're after in part 2. To get the equations, I'm telling you now how to get the equation using the Excel file. But I cannot illustrate how to get this one, maybe next class. But what I'm saying is there's a way, not the manual. But I'll show you the manual also later, but it's too long. The thing is, if you use this Excel file, you'll be able to find the M and the B. And that's what we're after, the Y, right? The Y equals MX plus B. That means the equation of this orange, if you connect this orange, what is this? Orange squares, we have the regression equation, regression line. What is the equation of that regression? What is the equation of that regression line? It is Y is equal to what? 0.38 or 0.36 plus 65. That's it. That's your equation already. Now, if you want to predict for 75, you just substitute, right? Because Y equals MX plus B. If you want to predict the glucose level of that person whose age is 75, you just substitute. You just substitute to that equation. And what is that equation? Y is equal to 0.39. What did I do? I estimated Y is equal to 0.39x plus 65. I used that Y equals MX plus B. Actually, that's the part 1. That's all about part 1 class. Part 2. That's all. Actually, part 1 and part 2 summarizes. No? This Excel file summarizes those two parts. But let me show very fast. I don't know if you can finish it. So I don't think I have to read that anymore. You understand the concept already. So this one I won't read anymore. It just says about what I told you already. Okay, it's just another example. This one, yeah, scatter plot. But what does this show? There's an error. There's an error. That's what it tells you. That there's an error, of course. That's why we just estimate, we predict. Because if we don't predict, there's no error. Why do you have to predict if there's no error? Because we just want to find the line of best fit. So not the exact, okay? Where is that? Oh, wait. Where's the... I wrote something here. How come it's not shown here now? So anyway, those things tells you about the error. Okay, this is what I wrote. Okay, remember this Y equals MX plus B because in part 2, that's what we're after. Not just this, but the coefficient of determination as well. Where did I get the 1.31? This one, it's given here. But later on, we will compute that. Remember the glucose level and the age? We use Excel file to compute it. But we can use the formula, but I use the Excel file. No? But I also illustrated to you how to use the formula to get those, right? To get those values. Now, this one is already given. 1.31x is also the intercept given. 2.4. Now the question is, what is the value of y if x is 3.5? Now you try to substitute, you will get 6.9 approximately. If you estimate or round off, you will get 7. So indeed, this equation is regression equation, or the regression line. It's the equation of the regression line, the line of best fit. If you want to predict your data which are not included here, okay, that's the reason. Because if they are here, why do you have to predict? Now, this one class is for the population. And this one is for the sample. But we will connect it to y equals mx plus b. That's why in this lesson, we'll just focus in y equals mx plus b. But these three are just the same. It just tells you that this one, you use it for the population. This one for the sample, but you're more familiar with this. That's why we will use this. Okay, so that's what we're after. So let's go to the example. But before that class, there's an assumption to have this model. These are the assumptions. I won't go into this, but when you take your quiz, you have to memorize this. This one only tells you that the error is 0. That's our assumption. Okay. With this assumption, we're able to find what? We're able to find the formula for the slope and the intercept with this assumption. And I will show you the formula later. But again, I was able to show to you that we can find slope and intercept using the Excel file. Okay. But not in detail because there's no time. So now, so we will compute because by hand. So I'll show you first how to compute. So I erase this because we don't need the y. We just need the squares of x. We don't need the square of y. This one we can use, but you're more familiar with this. So we use y equals mx plus b. So that's what okay. These are the formulas now, class. So we will use these formulas and this to get the m and the y intercept. But again, I was able to show to you in Excel file. We can get this too. So now let's discuss this, the number of chimpanzees and the percent successful hands. So this is your X, this is your Y. So now to apply the formula, you have to compute for X, Y, X squared. No need for this because you will just substitute this 4 into the formula. Doing that, substituting, you get this answer. Now I'll show to you that using Excel file, we can get also this answer. Okay, I'll show you the Excel file. This is about chimpanzee, right? Okay, there, you saw it, right? The Excel file. So we have the scatter plot of the number of chimpanzees and percent successful hands. So expect, class, that the coefficient of correlation is close to 1. In fact, it's close to 1. Look at the coefficient of correlation, 0.9. It's very high, remember? Remember the table? So because it really approximates a line, right? In fact, this is the line of best fit if you use the Excel file. Now, what is the equation of this line? The equation of this line, class, is the one this one. You notice the 5.44 is the same as this. The 5.44. I use Excel file to get the slope, but whereas in the PowerPoint we use the formula. Okay. Now look at the y-intercept. The same also. 31.64. I'm sorry, but this one is using Excel file. So really, technology can help us a lot. Okay. But the manual, to understand the concept, that's why we use it. Okay, class. So now, let's have another example. Actually, that's the concept already. So grade, and now we want to know the line of best fit between these two, the regression line. So this is X, this is Y. So again, the same thing. Similar, X, Y, we get X, Y, Y. Computation, using computation, you will find this, use this formula. Then I'll show to you that indeed, this grade and words and essay, this slope is 3.74 here. Grade and words on essay. Look at the slope, 3.74 using Excel file. And look at the scatter plot. And this one is the equation of, this is the regression equation, the orange. Now, if you want to get this, you have to get the slope and the intercept. So manually, it's shown here. That's why we compute it, right? So we did this to find the y-intercept. This one, we use this to find the slope manually, but we can use Excel file. Okay, that's why we get this answer for the mean, and okay, it's shown in the Excel file. So we have this. You notice I erased this, but actually, this is the right one. I'm sorry, because there's a difference because of the approximation. It's approximated. That is why they are different. But actually, the right one is really this, because if we look at the Excel file, it's indeed 145. Look at that, 145.2801. So it's the correct one. However, the reason for difference is because these are all approximations. We approximate the mean of the y. We also approximate the mean of the x and the slope. That is why we get a value different from the other one. That's possible. So this one or this is okay, no problem. So this now is your what? This is your equation now. This is what we're finding. This is what we're finding. So we can change this to the 145.27. So we have now the equation. We have now the equation of the regression line. So we can use this now to predict. Okay. So if we look at the we look at the Excel file. So the same. So our equation is y is equal to 3.75. So let's estimate x minus 145. We can just use 145 or 145.28. Now, if you'll notice, there's no grade of 95. So that's what we can predict. How many words on essay a student can give if his grade is 95? Then you just substitute. Just substitute into x, you get the answer. Okay, class? Now, the last one is the coefficient of determination. Now, what is this coefficient of determination? It's related to the coefficient. No? All you have to do is to square the r. What is your r? Square that, then you get 0.85. Indeed, that's the coefficient of determination, because if you look at the Excel file, there you are, 0.85, the same thing. Actually 0.86 now if you round it off. But we can consider 0.85. Now, this one comes from this, the coefficient of correlation, which is 0.92. It's still high, right? Still high, because the line of best fit is kind of close to the data. So square that, you get the coefficient of determination. So in effect, the coefficient of determination is the square of the coefficient of correlation. What does it tell you? It only tells you this. The coefficient of determination explains 85% of the variation in the number of words on the essay. In other words, exam grades strongly predict how many words a student will write in their essay. So that's what it says, okay? Okay, class. So actually that ends the week 9. So I want to show you more, but I don't think we have time because we just have like 1 minute to go. So that ends the week 9. So goodbye for now, class. See you next week.